Thank you. So the title for today's talk is Cloudy with a Chance of Chaos. Do you have your own shared responsibility model for security in the cloud ready? Before we get started, a little about myself. I'm Kushagra Sharma, Senior Security Engineer at Booking.com. So let's go briefly through the agenda for today. So we'll touch upon what's a shared responsibility model that exists out there today. We'll talk about what's changed in the last decade. Then we'll jump on to some of the challenges that the current model has. And then on switching gears, we'll talk briefly about Booking.com's cloud landscape and how we defined our own model for security in the cloud and the benefits of defining such a model. Then we'll touch upon how you can have a service enablement process that's sort of complementing the model once you have defined it. And then I'll drop a couple of things to ponder, which we have a hard time digesting ourselves. And then we'll touch upon some of the gray areas towards the very end of the presentation. And as a side note, I won't talk about generative AI more than thrice in the whole talk. So you're covered. So let's get started. Disclaimer, none of the work on the screen is mine, it's by AWS. So what's the shared responsibility model? It's basically drawing a line in sand and saying, on one side of things, it's a customer responsibility, whereas on the other side, it's AWS. And lines are blurry. So what the model says is, anything which is in the cloud, as a customer, you're responsible for your customer data, access management, configuration of services, operating system, network, and AWS basically is taking care of the whole virtualization layer all down to the physical infrastructure, the global networking backbone. So how I see it, it's basically a split between customers and cloud service providers' responsibility. It also helps you with compliance to a certain extent. And overall, you can say it enhances the overall security of your cloud landscape. This was just to set the premise. Now, over the past decade, the whole cloud landscape has changed drastically. You had introduction of new services, the whole shift towards managed services, and the threat landscape changed drastically, right? So what you see on the screen is the shared responsibility model that was published by AWS in 2013. This is how it looks in 2024, a decade later, and the only change is you changed to customer, Amazon changed to AWS. I'm not saying the model is flawed, but I'm saying over the decade, things changed a lot. And as a customer, we lack the clarity which a model should be providing. So we need something that goes a bit deeper and not as like an abstracted level of what's out there. So here's where the chaos begins. What are the challenges with the current shared responsibility model that's out there? First, as I said, it lacks clarity. There are not enough details for a customer to understand what falls in their scope versus the cloud provider. Second, limited to no guidance. There is no framework, no guidance that exists out there, which helps us as a customer to map out due to the high level of abstraction in the model itself. But what's interesting is Google Cloud has something called as the shared fate model, which basically is Google working with their customers, to have this mapping in place. I'm not saying that's a perfect model, but it's actually a good extension to what's out there. Third, multi-cloud. So different cloud providers have their own shared responsibility model, and it's really, there's nothing like one-size-fits-all model out there, which adds to the complexity. And fourth, the gray area. So some areas are left on how the customer perceives the model. So for one customer, it might be their responsibility. Some customer might think it's the cloud service provider responsibility, and at the end, there is chaos with no specific clarity out there. So until now, what I see it is that the cloud provider secures infrastructure, you secure everything you put on it. That's my understanding, but let's see how that changes as the talk progresses. So shifting gears a bit, what's Booking.com's cloud landscape in a nutshell? So as of today, we have over 2,500 AWS accounts. We make use of about 20 plus regions. We follow a cycle where we vet AWS services before they touch any production, pre-production environment. We have dynamic flavor boundaries and baselines. By flavor, we mean it's a variant of a baseline catered to a specific business unit or regulatory need, example PCI. And just like any other customer, we have AWS account level as well as OU level exceptions. So this is just to give an idea of the scale we operate in. But looking at a scale, we ran into the question that, okay, leave the cloud provider side of things separate. How do you define your own shared responsibility model as an organization to split out the responsibility between different teams, areas, and capability leads that you might have within the company, right? That's the part which is in your control and you can take some ownership of it. Because you don't want to run into an issue where different teams are thinking that, hey, it's that team doing it, or it's the scope of that team. And at the end, it's like a cycle where everyone thinks someone else should do it, and you introduce security risk. So that's what you want to avoid, right? So what's the need, or what do you get of defining your own shared responsibility model as a customer? First, responsibility and scope clarity. You basically list down the scope and responsibility of each of the areas and the teams out there. Second, ownership. Define which teams own what, because that's where things go south. Third, easy audits and reviews. So when you have a responsibility model laid out to such an extent, it's very easy to explain to your auditors who's owning what part of the infrastructure, who's owning specific controls, who owns the different layers of your security, and it sort of checks all the check boxes, as you say. And fourth, as I said, it reduces the chances of security gaps, because when you're mapping controls to your controls that you have on the infra layer, for example, it's very clear to see where the gaps that exist, if might be. So let's talk about our responsibility model on the control layer of things. So we have divided our model into 4 specific layers, also in line with the layered security approach that one must follow. So level 1 is basically organization-wide controls, which we call it as the non-negotiable controls. So here you talk about SCPs, global regional restrictions, service auto enablement like CloudTrail, guard duty, baseline resource protection. So you might have resources for the baseline deployment that you might want to protect, and security enforcement, so the same security enforcement that you want to enforce. So this layer is the non-negotiable layer that must exist no matter what. Second, these are organizational unit level controls. So here's where we put the baseline, and we have service restrictions, we have cross-environment access controls, service restrictions again via SCPs, and all the internal as well as external tooling deployments that you want to deploy across your org or to target to specific accounts or OUs. Also, you might see that there are account level exceptions. So in here, if you see on the legend on the left, we are basically telling for each of the components who's responsible, and in certain scenarios, there are multiple teams contributing to it. So for example, for account level exceptions, you have your GRC teams, security teams, platform teams, and based on your structure, actually contributing before an exception gets deployed into place. Now you might think it's nice to have this responsibility model listed out with clear ownership, but if you see from a developer's perspective, once they are building a service, they have clear understanding of what are the controls that are in place, so they don't have to worry about it. So for example, as a developer, I don't have to worry about ensuring that there's audit logging because the central security team is enabling CloudTrail at an org level. So it also gives visibility to the developers to see how it's working. The third layer, which we call it as the preventive and proactive baseline. Again, I spoke about baseline flavors, which we have very customized deployed into our organization. So here's what's happening is we have a global baseline that are a set of proactive and preventative controls that apply to all the accounts. But then we get the flexibility of having a subset of policies that are catered to a specific flavor, as we call it. So for example, PCI, where you want to be more restrictive. For example, sandbox layer, where you want to have certain additional detections. So this way, teams owning that specific flavor can actually deploy into that without touching the global layer, which we enforce centrally. And on the same lines, we have the fourth layer, which is called the monitoring baseline. So this is on the monitoring side of things. It could be a third-party tool like your CSPM, for example. And in here, we follow the same structure of having the mandatory global policies and, again, flavor-specific policies which you can target. So for example, you might want to monitor the usage of your root user. I hope none of you are using it, but that goes into the global policies. Then you might want to have specific PCI-related policies in line with PCI requirements that goes into your flavor A configuration. And then towards the bottom, depending on your structure, you might have central reporting pipeline to send these actionable alerts, contextualize them, enrich them. So again, mapping out the responsibilities of each of the blocks to specific teams or areas within your company. Now, there's a lot of text on the slide, but basically it boils down to that security and platform teams will always ensure that org-wide controls are there with secure defaults where possible. AWS accounts are baseline to meet both security as well as tooling needs, so integration with third-party toolings as well as internal tooling. You're also providing guidance to ensure that the service meets the security requirements early in the development cycle, so talk about IAC checks or shift left, as you call it. And then again, refining the controls as the business needs change, the threat landscapes change. So this is like the core responsibilities of the security team. On the AWS resource/account/OU owners, they'll be always responsible for ensuring the services can meet the security requirements, configuring the service with same defaults. So that's the customer or the development team's responsibility. Of course, you have controls to prevent things from happening, but the responsibility is with them. And of course, deciding which data ends up in which environment to not getting flagged. So overall, what it's doing is it's reducing duplication of work because everyone has a clear responsibility within your organization of what they're supposed to do and what they're not supposed to think too much about, because security is like a friend or a trusted friend behind their back. And it also enables development teams to move faster. Another interesting thing is it also enables to prevent scope creep, as you call it, because sometimes the scope keeps increasing just because you don't know who's supposed to work on that. Now, once you have the model defined, what it helps us is one of the core things that we do is the service enablement process. So I'm not sure how many of you work in a manner where you safe list cloud services before they are enabled in any environment. We do. So there are the 4 fundamental questions that we ask. First, do we have the necessary controls at every layer of the shared responsibility model for a specific cloud service? Does the service has valid compliance attestation carried out by the cloud service provider before it touches production? Because trust me, some of the services we want to use, they don't have the certification. So that's a big risk. Do you have enough visibility in terms of how the service works, in terms of logging, observability, things like that? And does the service use or share customer data for any other purpose? As a side note, there's a policy called AI Service Opt-out Policy on AWS, which you can enforce at the org level, telling AWS to not use data processed by the AI services. So in case you're interested, take a look at that. So now the sky is getting cleared a bit because you have a safe list approach. So how does this approach work? Perform a threat modeling for every service, regardless it's managed or not, because every managed service is different, it's not the same. Enable the service and its IAM namespace by a safe list approach. Also look into what are the critical actions that you might want to deny. Third, ensure you have the complete set of controls, again in line with your shared responsibility model, so you are sure every team is doing their part of things right. And have a control mapping to ensure that there are no gaps. This is where your GRC or technical risk compliance team might help you. Some of the things we use to have the safe list approaches using permission boundaries, SCPs, and also proactive controls where things, permission boundaries or SCPs cannot do it at the IAM level. Now, when you talk about the safe list approach, AWS is constantly launching new services, introducing new IAM namespace. So it really gets tricky, if you're safe listing each of the actions or critical actions one by one, because the services keep growing, but not the character limit. So how many of you here have ever hit into a character limit, be it permission boundary, SCP, or an IAM policy? Almost all, I would say. So one of the examples is the customer managed policy by AWS, which is the limit for customers is 6,144 character per policy. But if you look at AWS's own read-only policy, it has 65,202 characters, which is 9 times the limit for customers. It's understood that with the number of AWS services increasing and AWS carefully whitelisting all the actions, the size grows organically for wider scope roles. But just because it's a CSP, they have the flexibility, whereas the customer doesn't. And then you run into the vicious cycle of downsizing policies, finding the right balance between SCPs, permission boundaries, IAM policies, shifting your controls outside the native tooling. Another thing, when I talk about the review process or threat modeling, it's a long process because you collaborate with different teams and you get into a review cycle before you enable a service securely. But if you look at one of the interesting timelines, again, of AWS read-only policy, the first time I mentioned a GenAI service, AWS Bedrock was generally available in September 2023, but the read-only actions were only added by AWS to the policy in January 2024. That's about 4 months later, and I have examples which go as long as 7 months. So I don't have the internal details, but I do understand the review process is tough. But as a CSP, if they are not able to add the actions at the launch time, as a customer, it really gets difficult to review or carry out a thorough review when you're not sure about it. Because sometimes when there are new features introduced to existing services, they use the same IAM namespace. So you really need to be very careful or have a reiterative approach to things. Now, let's move on to some of the gray areas of the shared responsibility model, which also brings us to the very end of the talk. So first, the planted IAM entities, as we call it, which are service link roles. We have a dedicated slide upcoming. Then vulnerability and incident management. So this was the area that was touched upon early today in some of the talks, is that in most cases you require collaboration between the customer and the CSP for certain vulnerabilities and incident management. So it's not very clearly defined of whose responsibility it is, and that's why it's a gray area. Third, managed service. Again, cloud providers need to be on top of the things, to maintain or carry out their responsibilities, but nowhere this is explicitly mentioned, And oftentimes, customers are guessing whether they should be doing something about it or whether the CSP, for example. AWS service link roles. I'm not talking about service roles. It's the service link roles that are present in your account. So, fact sheet. Permission set managed and updated by AWS. The customer doesn't have any control over it. Location in your AWS account. Customer controls, which we showed in the 4 layers of the shared responsibility model, SCPs don't apply to service link controls. So it's technically a planted IAM entity in your AWS account for the AWS service to function, but the customer has no control over it. Doesn't sound right. So in my opinion, this should be an explicit responsibility of the CSP, also documented publicly. It shouldn't be a gray area for us to understand that, hey, you need this role for the service to perform, but the service technically can perform actions which can technically touch your data. And shouldn't the customer have control over the identities in the environment? So I'm totally fine my service not working because I have an SCP blocking it. But the other premise where it says these role needs to exist for the service to function is a bit, again, of a gray area. So on that note, it's almost towards the end of my presentation, but before I go, a recycle tip of the day in line with the shared fit model. So AWS does this good thing, so as with other cloud service providers, if your credentials of an IAM user, again, I hope you're not using any IAM users, gets leaked in any public repository, they have this policy called AWS Compromised Key Quarantine V2. Remember, V2 is like the latest version of the policy, and they're attached automatically to your IAM user, which blocks certain critical actions, including reserved instant purchases, so on and so forth, to limit the blast radius. So it's a very good detection in case you have IAM users to see in your CloudTrail if this policy is being attached, or for example, in the IAM user configuration if the policy ever is attached. So it's a good detection. Some of the CSPMs have this out of the box, but if you're not using one, it's a good one to have. And on that note, end my presentations, and happy to answer any questions that you might have. Thank you.
Start back here.
Great job. I'm curious, you mentioned threat modeling and like the service enablement process. For some of the larger services, like more PaaS, like SageMaker or whatnot, do you enable certain capabilities when they're required by the business piece by piece, and do you annually review those threat models and do reassessments?
Right, that's a good question. So we heavily use SageMaker, so that's a great example. So indeed, we do enable it feature by feature, but that again boils down to how it's implemented on AWS side. So as I said, some of the services have common IAM namespace. And if you were to allow that, you need to review the whole things which you want to deny, right? But for some services, they create additional IAM namespaces, which is easy as a customer to audit and also implement. So it boils down to how the implementation of the service is and what's the IAM namespace. But on the other side of things, we also don't want to block development teams, from using new capabilities. So for some things, we might have ISE checks instead, or detection controls, or certain monitoring in place to, have visibility at least.
So when you're going through and evaluating these new services, a lot of times they may have sharp edges, and you want to sort of tell your teams that, hey, use this service, but only in this one way. Like, how do you keep that on an ongoing basis and kind of keep that fresh and up to date?
Right, so ideally the process should start from your development teams telling what they want to do, right? So for us, the first thing is, to involve security early in your development cycle when you're thinking of how to use the service. So get the architecture diagrams in place to see what are the use cases. Because also when we enable a service, we want to enable it for everyone, right? Not just for that use case, which is your question, right? So that's when we take these feeds and then see how we can work together to, enable it in a compliant manner for everything. But for some services which are a bit too niche, then of course we are just enabling a certain use case. So that's always trying to find the balance to, review the service as a whole.
And then sort of on a related note, sometimes the shape or the threat model of the service can kind of change out from under you. Very recent one being DynamoDB allowing resource or table-based policies that allows you to share outside of the account. How do you stay on top of that, and with the rapid pace that the clouds are changing, to make sure that you don't miss something of that form?
Right, so it's interesting. In our sprint, there's a constant sprint called as the refinement, which basically is constantly refining the policies and all the controls, looking back historically of what we did. So as I said, it's not a one sprint job. You need to revisit the services. So we have this process where we revisit certain services, based on the announcements and the feeds we get, of course, and see what can be done differently or if something changed over time. So the refinement sprint is there to stay forever.
You talk about the proactive controls that you embedded. Can you speak a little bit more about how you manage individual pipelines, right, versus ensuring that proactive controls are implemented in those? I always find that to be a conflict.
Right. So one of the good things, at least at Booking.com, is we have a central deployment pipeline. So we either deploy using our own in-house pipeline or using like third-party tooling. So there are just two pipelines in place. So it's very easy for us to have coverage over those two. So what we have is we provision sort of a shared pipeline, like it's a downstream pipeline that every triggering pipeline needs to trigger. It's a prerequisite set in the CI configuration. And at the same time, we also do a parity check in terms of the number of repositories deploying into AWS compared to what's being scanned to get a parity check in case we have some coverage gaps.
Right. I think we're out of time for questions. So thanks, everyone, and everyone. Another hand for Kushagra, please.